All right, so we're going to substitute wherever there's an x, I'm going to substitute 3 tangent theta squared. But there is another thing we have to substitute, and that's dx. So dx is going to be 3 secant squared theta d theta. How many of you remembered that? 3 secant squared theta d theta. Good. If you didn't, write it in right now. You're probably thinking, boy, this is no way is going to turn out to be nice or straightforward, but actually watch this. 3 secant squared theta d theta over 36 plus 9 times 4 is 36. We have 36 plus 36 tangent squared theta. What do you want to do next? Yes, pull out the 3 and the 36. So you get 3 and the 36, and you'll get secant squared theta d theta over what? 1 plus tangent squared theta. Is that all right? Okay. And then I'm going to get 1/12 secant squared theta d theta over secant squared theta, right? And so this is going to be 1/12 the integral of d theta. And you're saying, uh-oh, I did this wrong. I messed up. But it's actually going to be 1/12 theta plus c. Now we got to go back, and x equals 3 tangent theta. What's tangent theta equal to? X over 3. You agree with that? So then what's theta equal to? Yeah, it is equal to the inverse, the arc tan or inverse tan of x over 3. That's kind of cool. Don't you think? Put your hand off, 2 feet off the ground if this makes sense. Hands on the table if it doesn't make sense. Oh, good, good. Getting better. Let's try another one. You try this one. So looking at the second one, not a bad idea to go 2x. Well, do this first. You have x equal to 1/2 secant theta. Dx is going to be 1/2 secant theta tangent theta d theta. And then you may even want to solve for theta. 2x equals secant theta. I like cosine theta is 1 over 2x. So theta is going to be the inverse cosine or arc cosine of 1 over 2x. Good place to start. These two are going to be used later. How many got that far? Any questions on that, how I got the dx and solved for theta? So now what we're going to do is we're going to substitute wherever there's an x, I'm going to put in 1/2 secant theta. And wherever there's a dx, I'm going to put in a 1/2 secant theta tangent theta d theta. So this was 5 times 1/2 secant theta tangent theta d theta. Do you see why I used this crazy 1/2 secant theta? No. Look at this. Cancels them right out. They're gone. They're gone. And then in the top, what you're going to end up with is 4. 1/2 squared is 4/4 secant squared theta minus 1 square root over 5 tangent theta d theta. And 4/4 is the same as what? 1. So I'm just going to take that out. And what's secant squared minus 1? Tangent squared, what's the square root of that? Yeah. Did I forget something?
Yeah. Isn't it tangent squared minus 1 is secant squared? Is that correct?
Yeah, it is tangent squared. So it's 1/5 integral of the square root of tangent squared times tangent. If you're bothered by this, remember that tangent squared theta plus 1 equals secant squared theta. Therefore, tangent squared theta is secant squared theta minus 1. A lot of things to think about here. You're doing great. So what's the square root of tangent squared? Tangent, what's tangent times tangent? Tangent squared. I know it looks a little bit of hocus pocus there. Now, what I would do here is I would use this again. I would use this one again and rewrite it as secant squared theta minus 1. Why would I do that? Yeah, because this antiderivative is tangent theta. This antiderivative is theta plus c. Does this look familiar? This isn't the same one I did before, is it? No. But it's got a little similarity to it. All right, so then this is going to be 1/5 the tangent of theta minus 1/5 theta plus c. And we said theta was the inverse or arc cosine. I shouldn't do it that way. I'm just going to call it the cosine inverse of 1/2x. Cosine inverse of 1/2x. And 1/5 the tangent of the inverse cosine of 1/2x. 1/5 inverse cosine 1/2x plus c. And what is, when we make a triangle, cosine inverse of 1/2x, where does the 1 go? Opposite, hypotenuse, or adjacent? Where does the 2x go? Hypotenuse. So you can see that this is the square root of 4x squared minus 1. So my final, at last, answer is 1/5. The tangent is square root of 4x squared minus 1 over 2x, because tangent, I'm sorry, over 1, opposite over adjacent, minus 1/5 cosine inverse of 1/2x plus c. This is my final answer. Did anybody get close? Good, 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 good. And that is trig substitution. Really 4 steps. The first step is take your x and take the derivative. Get that first. That's the first thing I would do. I would do that step 1 before you forget. Step 2, I would solve for theta. I would solve for theta. Then step 3, you're just kind of substituting in. You're substituting all the stuff that you did before, the x and the dx. And then you simplify it. And then at the very end, now you're going to step 4. You're going to substitute back, sub back to x, and then simplify. So interesting problem, challenging problem, but you can do it. For homework, you're going to do E, I, L. I wish that spelled something fun, but it doesn't. And 12. Those 4. That is plenty for homework. And then practice on integration by parts, other substitutions, this review of this. And this is our last thing. We'll review tomorrow. Test will be on Thursday.